If you've been scrolling through science headlines lately, you may have seen a story that sounds like something out of a sci-fi movie. Scientists discover a giant underground hole hidden beneath North America, and it's not just any hole, it's a massive geological anomaly deep within the Earth's mantle. Reports are calling it one of the most intriguing tectonic shifts ever recorded. But before you picture a gaping sinkhole ready to swallow entire cities, let's clear up what this discovery really means. This so-called hole is not a cavity you could rappel into. Instead, it's an enormous void, or zone of less dense rock, forming thousands of miles beneath the surface. Geologists describe it as a region where seismic waves travel unexpectedly fast or slow, indicating that parts of the Earth's mantle are missing, melting, or behaving in ways that defy what we thought we knew about plate tectonics. For years, hints of this hidden hole under North America have puzzled researchers. But only recently, thanks to advanced seismic imaging and satellite data, have they begun to map its true size and scope. The idea that there is a growing underground void beneath an entire continent sounds like the plot of a disaster movie, yet the science is real and the stakes are high. This discovery could help explain unusual earthquake patterns, potential volcanic threats, or even long-term shifts in the North American landscape. Some researchers suggest that this geological anomaly could be the missing piece in understanding how the continent's tectonic plates recycle themselves. Others wonder if it signals something far more dramatic, like the early signs of a supervolcano or a massive tectonic shift waiting to happen. In this video, we'll explore the facts and the mysteries behind this underground hole. You'll learn what scientists found when they looked deep under North America, how they uncovered it using seismic waves like an Earth-sized CT scan, why it appears to be growing, and what it might mean for the millions of people living above. From cutting-edge research to controversial theories, this story will take you on a journey into the depths of our planet and challenge what you thought you knew about the solid ground beneath your feet. Stay with us as we unravel the secrets of this hidden hole under North America and reveal why scientists are both fascinated and concerned by this expanding geological anomaly. What scientists really found deep below. When people first hear that scientists have found a giant underground hole beneath North America, it sparks images of a massive empty space that could open up and swallow towns or forests whole. But the truth is more fascinating than any sci-fi scene. This discovery is not an ordinary hole or cavern. Instead, it is a vast geological anomaly buried deep within the Earth's mantle. To put its size into perspective, researchers estimate that this hidden void could represent an area with over 100,000 cubic kilometers of rock behaving in unexpected ways or even appearing to be partially missing when compared to surrounding mantle material. The heart of this strange feature lies beneath several regions that have long been of interest to geologists. One area is the Cascadia subduction zone off the west coast of North America, which stretches from northern California up through Oregon, Washington, and into British Columbia. This region is already known as one of the most dangerous earthquake zones in North America because of the way tectonic plates collide and slide beneath one another here. But new imaging suggests that deep beneath this subduction zone, there is an enormous zone where mantle rock seems to be shifting or melting in ways that create a huge gap. Another hotspot sits beneath the Hudson Bay region of Canada. This spot has puzzled scientists for decades. It is known for having an unusually weak gravitational field compared to the rest of North America. For a long time, researchers suspected that some massive underground process was responsible for this anomaly, but they lacked the precise imaging to see what was really there. Recent seismic data now supports the idea that the Hudson Bay Depression is linked to this wider hidden hole beneath the continent, where part of the mantle is less dense than it should be. So how did scientists actually detect this vast underground void? The answer lies in the remarkable technology that allows geologists to peer inside the Earth without ever having to drill miles below the surface. Every time an earthquake happens, it sends seismic waves racing through the planet. These waves move at different speeds depending on the type of rock and the temperature and density of the material they pass through. By setting up thousands of sensors across North America and even on the ocean floor, scientists have turned the planet into a giant laboratory. When they fed the seismic wave data into advanced tomography models, the images they got back showed clear patterns of unusual gaps and pockets where the mantle rock should have been more solid and uniform. To confirm these surprising images, researchers also turned to satellite measurements. Precise data from satellites orbiting Earth can detect tiny shifts in gravity caused by variations in mass deep below the surface. When multiple lines of evidence, seismic waves, gravitational data, and even magnetic anomalies, point in the same direction, scientists grow more confident that what they're seeing is real. In this case, the combined data painted a picture of a vast, irregular region under North America where the mantle's density is far lower than expected. This is not the first time that geologists have found such strange features. A similar but smaller anomaly was discovered beneath the ice of Antarctica. Using the same seismic tomography, researchers found an area under Marie Byrd Land that appears to be home to an ancient mantle plume. Another example lies beneath Yellowstone National Park in the United States, where an immense magma chamber fuels the famous geysers and hot springs. That chamber is so large that it could fill the Grand Canyon multiple times. Yet even Yellowstone's magma reservoir seems modest compared to the sheer size of this newly mapped underground hole stretching under North America. As news of this discovery spread, some geologists began to wonder if the hidden gap could be linked to an ancient supervolcano that has long since gone dormant, or if it might be the early sign of a new mantle plume rising slowly through the Earth's layers. A mantle plume is like a giant column of hot, molten rock that pushes its way upward, creating volcanic hotspots on the surface. While there is still debate about whether this void represents a plume in the making or something else entirely, the idea has sparked heated discussions within the scientific community. Some experts argue that the gap could simply be a byproduct of normal tectonic processes, where the Pacific plate pushes under the North American plate, creating spaces as old oceanic crust melts and sinks into the mantle. Others think there could be more to the story. If the hidden hole continues to grow, it might change how the continent shifts, possibly influencing everything from earthquakes along the Pacific Northwest to volcanic activity that could shape North America's future. One thing is certain, this is not just an empty space sitting quietly in the dark. It is an active, changing part of our planet's inner workings, a reminder that the solid ground beneath our feet is far from stable. Scientists are only beginning to understand what this underground hole truly means for the continent above. In the next part of our journey, we'll explore how these researchers were able to find something so massive and so well hidden, using technology that transforms our understanding of what lies deep within the Earth. Let me know when you're ready for the next section and we'll keep digging deeper into this remarkable discovery. How scientists uncovered the hidden void beneath North America. And most people never think about what lies deep under their feet, but for the scientists who dedicate their lives to studying Earth's interior, the quest to see through miles of solid rock is a daily challenge. Finding a giant underground hole beneath North America was not something that happened overnight. It took decades of technological advances, thousands of carefully placed sensors, and a new generation of digital tools that made it possible to reveal something that had been hiding in plain sight for centuries. The first clues about this hidden void came from studying the way seismic waves travel through the Earth. Every time an earthquake shakes the ground, it sends ripples outward in all directions. These seismic waves can pass through solid rock, molten magma, and even pockets of water trapped deep beneath the crust. But as they move, they speed up or slow down depending on what they encounter. By measuring these subtle changes in speed, scientists can build a map of what lies below. Think of it as using sound waves to see, almost like how bats navigate in the dark, or how a doctor uses a CT scan to look inside the human body. Institutions like the United States Geological Survey and the University of Washington have been at the forefront of this research for years. In the Pacific Northwest, the Cascadia subduction zone has long been a natural laboratory for studying earthquakes and tectonic shifts. Researchers installed dense networks of seismic arrays, each containing dozens or even hundreds of sensitive instruments spread across vast distances. These arrays pick up the faintest vibrations in the Earth and feed that data back to supercomputers that can process millions of data points. But the land-based sensors were not enough. To get a complete picture, scientists needed to understand what was happening beneath the ocean floor as well. This led to the deployment of ocean-bottom seismometers, which are special instruments designed to withstand the crushing pressures of the deep sea. These devices are placed directly on the seabed, where they listen for earthquakes that may originate in places humans could never reach. The information they capture fills in the missing pieces of the puzzle, allowing geologists to create a three-dimensional map of the mantle beneath North America. One breakthrough came when researchers began combining seismic data with GPS measurements. You might think of GPS as something you use to navigate city streets, but geologists rely on it to track how the Earth's surface shifts over time. By placing GPS stations in precise locations, they can detect tiny movements that occur as tectonic plates slide past one another or when the ground slowly lifts or sinks. In North America, these shifts happen at an average rate of about a few centimeters each year, but over centuries, these tiny changes add up, hinting at massive forces moving below. Perhaps one of the most remarkable aspects of this discovery is how artificial intelligence now plays a role in helping scientists see what they could not see before. The sheer volume of seismic and GPS data is so huge that it would take human researchers years to analyze it manually. But with advanced machine learning algorithms, computers can sift through millions of signals, spotting unusual patterns that might go unnoticed. AI models can highlight areas where seismic waves slow down dramatically or where gravity readings from satellites show unexpected dips, both of which can signal a hidden gap or void within the mantle. A powerful example of this kind of technology in action can be found in Antarctica. Researchers there discovered an enormous anomaly under Marie Byrd Land, one of the most remote parts of the continent. Just like with the North American void, they used a combination of seismic arrays and satellite gravity measurements to spot what they believe is an ancient mantle plume or a pocket of molten rock that has been trapped for millions of years. The same methods were later applied in Greenland, where scientists found evidence of a plume-like structure that could explain unusual melting patterns beneath the thick ice sheet. One of the most intriguing pieces of evidence supporting the existence of the North American void comes from how seismic waves behave in this region compared to others. In normal mantle rock, seismic waves travel at predictable speeds. But when they pass through the hidden hole, they can slow down or even scatter in unexpected ways. These differences in seismic velocity, sometimes just fractions of a percentage, become critical clues. When plotted on a three-dimensional model, they reveal a shape and size that would otherwise be invisible. Bringing all this together, seismic arrays scattered across land and sea, ocean bottom seismometers listening in the deepest trenches, GPS stations tracking the slow drift of the continent, and AI that pieces together the puzzle. Scientists now have a clearer view of what lies beneath North America than ever before. The image that emerges is a vast, irregular region stretching for hundreds of miles, a hidden void that seems to be slowly changing the way the continent sits on the mantle below. This discovery is not just an academic curiosity. Understanding where this anomaly lies and how it behaves could be vital for predicting future earthquakes, volcanic eruptions, or even subtle shifts that affect entire coastlines. It's a reminder that the solid ground beneath us is far more dynamic than it appears on the surface. In the next part of our exploration, we will look at why this underground hole seems to be growing and what that could mean for the future of North America and everyone living above this restless, shifting geological world. Why the hidden hole keeps growing beneath us. It is one thing to know that there is a vast underground void buried deep beneath North America, but it is another to realize that this geological anomaly appears to be slowly expanding. To understand why, we have to look at how the Earth's crust works, how tectonic plates interact, and why the forces that keep our planet alive are never still, even if we can't see them with our eyes. The surface of the Earth is not one solid shell but a patchwork of giant plates that float on top of the semi-fluid mantle. These tectonic plates constantly move, shifting past each other, colliding, or sliding underneath one another in what scientists call subduction zones. North America is perched on one of the largest plates on Earth, slowly drifting at an average rate of about 2 to 3 centimeters every year. That may not sound like much, but over a human lifetime or 1,000 years, this steady creep can open oceans, raise mountains, and create deep trenches where plates collide. One of the most active and studied regions is the Cascadia subduction zone along the Pacific Northwest. Here, the denser oceanic plate dives beneath the lighter continental plate, dragging rock deep into the mantle where it melts and recycles. As the oceanic plate sinks, it heats up, releasing fluids that lower the melting point of surrounding rocks. This process creates pockets of molten material that can collect into vast magma chambers or leave behind gaps and channels where solid rock used to be. Over millions of years, this constant cycle builds up new crust at mid-ocean ridges while pulling older crust down into the depths, fueling the dynamic engine that reshapes continents. Inside these subduction zones, the melting and movement of rock do not happen evenly. Some parts of the mantle may melt more rapidly than others. Fluids released by the descending plate can weaken rock layers, creating zones of less dense material. Over time, these weakened areas can expand, forming what scientists describe as a low-density anomaly. This is what they believe is happening beneath parts of North America. The hole is not empty space like a cavern but a region where the mantle is behaving in a way that makes it appear less dense to seismic waves and gravitational measurements. Some researchers argue that this underground gap may also be connected to deeper mantle plumes. A mantle plume is like a giant column of hot rock that rises from deep within the Earth, sometimes pushing all the way to the crust and creating volcanic hotspots on the surface. The Hawaiian Islands, for example, were born from such a plume. If there is a plume beneath North America, it could help explain the unusual heat and melting seen in this region. Studies using seismic tomography have found hints of plume-like structures beneath the western part of the continent, feeding speculation that this rising heat may be carving out parts of the mantle, contributing to the growth of the void. But the story does not end with just heat and rock movement. Some scientists are exploring whether the rapid melting of glaciers could be playing a surprising role in this process. As glaciers shrink due to climate change, the weight that once pressed down on parts of North America is lifting. This loss of weight triggers something called isostatic rebound, where the crust slowly rises to find a new balance. This rebound affects not just the surface but the entire structure beneath it. The sudden shift in pressure can cause faults to slip and fluids to move, potentially speeding up melting in parts of the mantle. In regions like Hudson Bay, which was buried under massive ice sheets during the last ice age, the crust is still rebounding even thousands of years later. That ongoing adjustment may be linked to the gravitational anomalies and low-density pockets that scientists now connect to the larger hidden hole under the continent. Not everyone in the geological community agrees on what exactly is happening. Some experts say that calling this feature a hole is misleading because it gives the impression of a single empty space when, in reality, it is more like a patchwork of weak zones, fluid pockets, and partially melted rock spread across a vast area. They argue that these features are natural byproducts of plate tectonics and subduction, nothing more than a sign that Earth's recycling system is working as it always has. Others believe the size and changing shape of this anomaly deserve closer attention. They point to unexpected shifts in seismic activity, sudden slips along fault lines, and unusual patterns of volcanic behavior in regions that overlap with the void. If this hidden gap continues to grow, it could mean that large sections of North America are slowly adjusting in ways that scientists do not yet fully understand. There is still so much to learn. Some researchers are now drilling deep boreholes and using new sensors to study how fluids move through these hidden channels. Others are testing models that connect surface changes, like glacier retreat, to the movement of rock far below. The questions keep coming. Could these gaps affect earthquake risks? Might they change how the continent responds to stress from other plates? Or are they simply ancient scars from millions of years of collisions and volcanic eruptions? In the end, the idea that a hidden hole is growing under North America reminds us that the Earth is never as solid as it seems. Beneath the forests, mountains, and cities, there is an entire world in motion, a place where rock melts, flows, and sometimes disappears into the deep. Understanding why this void exists and how it changes is not just about solving a geological puzzle. It is about preparing for what those changes could mean for life above ground. In the next chapter, we will look at how similar features have shaped the planet in the past, and what they might tell us about what could come next. What history teaches us about hidden void? When people first hear that there is a giant underground hole expanding beneath North America, it can sound like something entirely new and without precedent. Yet when you look back through geological history, it becomes clear that our planet is full of similar hidden voids, magma chambers, and mantle anomalies that have shaped the land above in dramatic ways. These case studies help us understand not only what is happening now but what might come in the future as the hidden gap beneath North America continues to grow. One of the most famous examples of a massive underground feature is the Yellowstone magma chamber. Beneath the peaceful forests and steaming geysers of Yellowstone National Park lies an enormous pocket of partially melted rock that has been fueling eruptions and geothermal activity for millions of years. The Yellowstone hotspot is one of the largest known magma chambers on Earth, stretching for many miles beneath the surface. Some studies estimate that the shallowest parts of this chamber alone could hold enough material to fill the Grand Canyon several times over. Scientists have mapped this chamber using seismic tomography, the same technology that revealed the hidden void beneath North America. What they found was a vast network of partially molten rock connected to even deeper pockets that stretch far into the mantle. While Yellowstone's last major eruption happened over 600,000 years ago, the presence of this enormous magma body is a powerful reminder of how much energy can be stored beneath the surface. Moving thousands of miles away from the American West, another strange anomaly lurks in the Atlantic Ocean. Sometimes called the Bermuda Blob, this mysterious region under the seafloor near the Bermuda Triangle has fascinated geologists and conspiracy theorists alike. Using seismic imaging and gravity data, researchers have detected a massive low-density zone that some believe could be remnants of an ancient mantle plume or a slowly draining magma reservoir. While it is not as well studied as Yellowstone, the Bermuda Blob shows how vast pockets of unusual rock or melted material can exist undetected for millions of years, influencing everything from seafloor spreading to subtle changes in ocean currents above. Even more dramatic in scale are the ancient flood basalt provinces known as the Siberian Traps. Over 250 million years ago, this region experienced one of the largest volcanic events in Earth's history. For hundreds of thousands of years, massive fissures in the ground spewed out rivers of molten lava, covering what is now Siberia with layers upon layers of basalt rock. Geologists believe that deep beneath the Siberian Traps lies an enormous reservoir of partially melted mantle material that once fed this catastrophic eruption. Some estimates suggest that the total volume of magma erupted during this period was enough to fill entire ocean basins. The environmental impact was devastating, triggering a mass extinction event that wiped out the majority of life on Earth at the time. While the Siberian Traps are ancient and mostly dormant today, they serve as a reminder that large mantle anomalies can unleash unimaginable forces when the conditions are right. Comparing these well-known features to the hidden hole beneath North America gives us some perspective. The void beneath Yellowstone's magma chamber is massive, but it appears more localized than the newly discovered anomaly stretching beneath the Cascadia subduction zone and parts of the Hudson Bay region. The Bermuda Blob is offshore and not fully understood, yet its gravity signature hints at a comparable zone of low-density rock. The Siberian Traps reveal what can happen when a huge mantle plume rises and empties its molten contents on the surface. While the North American gap has not produced anything nearly as catastrophic, the similarities in structure make geologists wonder if they are looking at a feature that could someday become more active. Throughout history, Earth has proven that its hidden voids can influence dramatic surface events. Ancient mega-earthquakes are often linked to these mantle anomalies and subduction zones. The Cascadia region itself has a terrifying history. In the early 1700s, a massive earthquake struck the Pacific Northwest, creating a tsunami that reached all the way to Japan. This event, known as the Cascadia megathrust earthquake, was only fully understood when researchers pieced together oral histories from indigenous communities and physical evidence buried deep in coastal sediments. Today, some scientists worry that the hidden gap beneath this region could affect how stress builds up along the fault, possibly influencing when and how the next big quake will occur. Volcanic eruptions are another piece of this puzzle. Many of the world's most powerful eruptions can be traced back to mantle plumes and giant magma chambers like the one under Yellowstone. When pressure builds in these underground reservoirs, it can push molten rock toward the surface in explosive bursts that reshape entire landscapes. While the hidden hole under North America is not a confirmed magma chamber, its unusual heat and low-density rock raise questions about whether it could someday feed new volcanic activity in unexpected places. Of course, big discoveries like this often attract strange theories. For decades, the idea of a hollow Earth has appeared in books, movies, and conspiracy circles. According to this theory, vast underground tunnels and enormous caverns connect different parts of the planet, sometimes even housing entire ecosystems or advanced civilizations. There are also stories about secret military bases and massive underground cities hidden inside Earth's crust. These tales make for good entertainment but fall apart under scientific scrutiny. Real seismic imaging shows that while pockets of low-density rock and magma chambers exist, they are far from hollow spaces big enough to walk through. The pressures and temperatures at those depths would make any giant cavity unstable and impossible to maintain. Beyond North America, other continents have their own underground mysteries. Under Asia, scientists have found evidence of a giant mantle anomaly beneath Tibet that might help explain the dramatic uplift of the Himalayan mountains. In Africa, the East African Rift is home to another deep plume that appears to be splitting the continent apart over millions of years. Even under the oceans, researchers have discovered massive gaps in the mantle where plates pull apart, allowing magma to rise and form new seafloor. Each of these features reminds us that hidden voids are not rare flukes but part of the natural process that keeps the planet's surface alive and ever-changing. These global case studies highlight an important lesson. Whether it is the Yellowstone magma chamber, the Bermuda Blob, or the ancient flood basalts of the Siberian Traps, massive underground features can lie silent for thousands or millions of years before bursting to life in ways that reshape everything above them. As scientists continue to study the hidden hole beneath North America, they draw on these examples to ask what might happen if this anomaly keeps growing. Could it change how earthquakes strike the Pacific coast? Might it feed volcanic hotspots that have not yet awakened? Or will it stay quietly hidden, another piece of Earth's inner workings that reminds us how much we still have to learn about the ground we stand on? What history shows us is clear. When it comes to our planet, the most powerful forces are often the ones we never see. In the next section, we will look at what these discoveries could mean for real people living above them, and what risks or surprises the future may hold. Could this hidden void trigger a mega disaster? Whenever people hear that a giant underground hole is growing beneath North America, the first question is always the same. Is it a sign of an imminent disaster? Could this anomaly deep in the Earth's mantle lead to the next mega-earthquake or even unleash a supervolcano eruption that could blanket the skies in ash? While scientists urge caution and careful study, the sheer scale of what lies hidden beneath the continent naturally fuels worry and speculation about what could happen if nature decides to shift its weight. One of the biggest fears tied to this underground void is whether it could change the way earthquakes occur in some of the most active zones in North America. The Cascadia subduction zone, where the Pacific plate pushes beneath the North American plate, has already proven itself capable of unleashing enormous seismic events. In the year 1700, this fault line produced one of the largest earthquakes in the region's history. The shaking was so intense that it sent a tsunami racing across the Pacific Ocean, striking the coast of Japan with little warning. This ancient event, pieced together from geological clues and indigenous oral histories, shows that the region has a history of sudden, devastating shifts. Modern science has shown that subduction zones like Cascadia store massive amounts of stress over centuries. When that stress is finally released, it can move the seafloor by meters in just seconds. Some researchers believe that the hidden void beneath this region could influence how and where this stress builds. If pockets of low-density rock or partially melted mantle shift the balance, they might make certain sections of the fault more likely to slip all at once, increasing the odds of a mega-earthquake. The possibility of a supervolcano eruption is another source of unease when scientists talk about huge underground anomalies. North America is already home to Yellowstone, a well-known supervolcano that draws thousands of visitors every year with its spectacular geysers and hot springs. Beneath Yellowstone sits one of the largest magma chambers on Earth, and while it remains quiet today, its history reminds us that large underground reservoirs of molten rock can become explosive under the right conditions. The newly discovered void beneath parts of North America is not exactly the same as Yellowstone's magma chamber, but the fact that it shows signs of heat and partially melted rock raises questions about whether similar pressures could build over time. Could this hidden gap feed new volcanic systems in the distant future? So far, there is no direct evidence that it is linked to an active supervolcano, but scientists continue to monitor heat flow and seismic activity to catch any hints of rising magma. For coastal communities, the fear of tsunamis is very real. When tectonic plates shift suddenly under the ocean, they can displace huge volumes of water in moments, sending waves racing toward shorelines at jetliner speeds. The Tohoku earthquake in Japan is one of the starkest examples in modern history. In 2011, a powerful undersea quake sent a tsunami crashing into coastal towns, destroying homes, flooding entire cities, and triggering the Fukushima nuclear disaster. The same kind of scenario could unfold along the Pacific Northwest if the Cascadia subduction zone were to rupture again. Some experts wonder if the hidden void's impact on how the plates interact could change the timing or intensity of such an event. Millions of people live along the western edge of North America, from Vancouver and Seattle to Portland and coastal communities farther south. Cities that rely on harbors, power plants, and infrastructure near the shoreline would all be in the path of a major tsunami. Beyond the sudden disasters like earthquakes and tsunamis, there are long-term economic and environmental impacts to think about too. Oil and gas drilling operations often tap into geological formations that lie above or alongside these deeper mantle zones. If the ground shifts in unexpected ways, it could disrupt wells, pipelines, or even cause land to sink unevenly, a process known as subsidence. Regions near the void, like parts of British Columbia or Alaska, are also known for their valuable mineral deposits. A growing anomaly might shift the ground enough to change the flow of groundwater, creating new risks for contamination or unexpected flooding in places where communities rely on wells and aquifers. Some cities already sit near or on top of major fault lines that could be affected by deeper changes underground. Anchorage, Alaska, experienced one of North America's most powerful quakes in the 1960s. Known as the Good Friday earthquake, it ripped apart roads, toppled buildings, and triggered landslides that reshaped the coastline. Back then, no one knew about the kind of deep anomalies that scientists are mapping today. But researchers now wonder if hidden gaps in the mantle could help explain why some quakes strike with such force and cause more damage than surface faults alone would suggest. With all these possibilities, it is easy to see why headlines sometimes warn of apocalyptic scenarios. Yet the truth is more complicated. While the idea of a massive underground hole growing larger each year is unsettling, most geologists agree that this does not mean the Earth is on the verge of tearing itself apart overnight. The processes that shape these features move on geological timescales, unfolding over thousands or millions of years. This means there is time to study what is happening and plan for the risks that exist, like major quakes that are certain to happen someday along well-known fault lines. Scientists emphasize that preparation, not panic, is the right response. The existence of this hidden void is a sign that our models of how the continent moves and shifts must keep evolving. Improved seismic monitoring, better building codes, and smarter city planning can make communities more resilient. In cities like Seattle and Vancouver, engineers are already working to reinforce bridges and skyscrapers to withstand the next big quake, whether it comes tomorrow or centuries from now. People sometimes ask how many are truly at risk. Along the Cascadia subduction zone alone, millions of people live within the region that could feel the effects of a mega quake. Add the broader areas influenced by volcanic activity, tsunamis, and possible shifts in groundwater, and the number rises even higher. From small coastal villages to major cities, entire economies depend on stable ground that might not be as stable as it seems. The key lesson is that our planet is alive beneath us, constantly reshaping itself in ways we do not always understand. A hidden void deep in the mantle is a reminder that what happens out of sight can change everything above. While headlines may stir fear with dramatic predictions, the real story is that knowledge gives us the power to prepare. By watching these changes closely, scientists can warn of shifting risks, helping millions of people protect homes, families, and futures. In the next part of this journey, we will look at what scientists plan to do now that this secret is out in the open. From new satellite missions to the latest in artificial intelligence, the tools that help us watch the Earth from within are evolving fast. And with them comes the hope that by better understanding these hidden forces, we can live safely on a planet that is always in motion. What the future holds for this hidden threat. With so much still unknown about the giant underground hole beneath North America, scientists are more determined than ever to keep watching and learning. The good news is that today's technology gives researchers more tools than any generation before to monitor this mysterious void and understand what it means for the people living above it. The work to uncover its secrets is far from over, and every new breakthrough brings fresh questions about what could happen next and whether there are ways to reduce the risks that come with living on a restless planet. One of the most important steps scientists are taking right now is expanding their network of sensors across the continent and into the surrounding ocean floor. Seismic arrays planted in remote forests, plains, and even deep beneath the sea are listening for the faintest vibrations that ripple through Earth's crust. These vibrations reveal how the hidden hole is behaving over time. Is it growing faster than expected? Are new pockets forming? Could stress be shifting in ways that might set off earthquakes or feed volcanic activity? These are the questions that researchers want to answer by collecting more data every day. Beyond ground sensors, new satellite missions are now helping scientists see changes in the Earth's surface that could be tied to what is happening deep below. Satellites equipped with radar can detect even the slightest rise or fall in the land, sometimes measuring changes as small as a few millimeters. Over months or years, these subtle shifts can reveal where the crust is swelling upward because of rising magma or sinking because of subsurface voids growing larger. Plans for future satellite launches will put more eyes in the sky, allowing scientists to watch the entire region in almost real time. Deep Earth probes are also playing a role in solving this puzzle. These special drills can reach kilometers into the crust, gathering samples of rock and fluids that give clues about temperatures and pressures far below. While no human has ever drilled into the mantle itself, every meter closer helps build a clearer picture of how the underground hull is forming and changing. Some researchers even dream of developing new types of sensors that can survive in extreme heat and crushing pressure, opening the door to studying the mantle more directly than ever before. Artificial intelligence is changing the game in ways that were hard to imagine just a few decades ago. Machine learning systems can now analyze the massive streams of data flowing in from seismic sensors, satellites, and GPS stations. These smart algorithms can pick out patterns and subtle signals that might otherwise be missed. In places like Japan, AI is already being used to forecast the likelihood of aftershocks following large quakes. Scientists hope that similar technology could help them predict when stress might reach a breaking point in regions above the hidden void, giving people more time to prepare. Of course, even with the best technology, no one can stop the Earth from moving. But there are steps communities can take to reduce the damage when nature does what it has always done. Emergency plans that include evacuation routes, early warning systems for tsunamis, and regular earthquake drills make a huge difference when seconds count. In cities across the Pacific Northwest, architects and engineers are reinforcing buildings to survive strong shaking. New building codes encourage stronger foundations, flexible materials, and designs that can sway without collapsing. Ordinary people also have a role to play. Having a plan for what to do when the ground shakes or when sirens warn of an approaching wave could save thousands of lives. Families are learning how to stock emergency supplies, secure heavy furniture, and stay connected during a crisis. Communities that invest in public awareness campaigns tend to recover faster when disaster does strike. One of the most promising signs for the future is how countries are learning to share information. Earthquakes and tectonic shifts do not stop at borders, so global collaboration is essential. Nations now exchange seismic data through international networks that let researchers spot unusual activity anywhere in the world. When an earthquake hits the Pacific, for example, the signals can be detected by stations as far away as Europe, helping to fine-tune global models of how the planet's plates interact. Some countries are also working together to launch new satellite missions that will track subtle changes in Earth's crust over time. All this progress does not erase the sense of awe and worry that comes with living above forces we can never fully control. Some scientists say that the hidden hole beneath North America is a reminder that the Earth's crust might be more fragile than we have long believed. For centuries, people saw mountains and plains as symbols of stability, but now we know that what seems solid is constantly shifting and changing shape deep below. This understanding does not have to inspire fear. Instead, it shows the importance of respecting the planet's power and planning wisely for the surprises it can deliver. Looking ahead, researchers will keep watching, measuring, and testing new ideas. They will keep asking whether the void beneath North America is just one piece of a bigger story unfolding around the world. Are there more hidden gaps beneath other continents that could change the way we think about plate tectonics? Could new discoveries challenge what we believe about how the Earth recycles its crust and reshapes entire landscapes? For now, the answers are still forming, buried deep in rock and heat miles beneath our feet. What is certain is that this hidden anomaly will remain one of the most closely studied features on Earth for decades to come. As long as we keep searching for answers, we stand a better chance of living safely and confidently on a planet that never stops changing. And that, more than anything, is what the future must hold as we learn to share our world with the powerful forces moving silently below. What this giant underground hole means for us all. Now that you have traveled deep beneath North America's surface, you can see why scientists are so fascinated and sometimes concerned by this giant underground hole. From its discovery through advanced seismic imaging and satellite data to the ongoing research revealing how it keeps growing, this hidden void is much more than an empty space. It is a vast, shifting region in the Earth's mantle that could change the way we think about tectonic movement, earthquake preparation, and even the possibility of new volcanic activity in the future. We have learned how this anomaly was found using the same tools that mapped Yellowstone's magma chamber and the Bermuda Blob. We have seen how theories about mantle plumes, subduction zones, and even climate change might all play a role in how this hidden gap continues to expand. We explored the potential risks, from mega earthquakes and tsunamis to the economic impacts on cities and industries that rely on stable ground. Most importantly, we discovered that while the idea of a giant underground hole North America update makes headlines, the real story is about how scientists, engineers, and everyday people can prepare for what the Earth might do next. The greatest mystery is that despite all our technology and knowledge, much of this hidden world remains unexplored. New tectonic discoveries remind us that the ground beneath us is alive, constantly reshaping the surface in ways that can surprise us at any moment. That is why research, monitoring, and sharing what we learn are so vital. Do you think this hidden void is nature's way of reshaping North America? Tell us your thoughts below. And if you enjoyed this journey into the depths of our restless planet, make sure you like this video, leave a comment, and subscribe for more mind-blowing science stories that reveal the secrets of the Earth we all call home.